Welcome to this PMP video for Lesson 5, Time Management Planning. I've basically broken down time management into two different sections, and the reason being is it's very comprehensive. There are lots of tools and techniques and lots of things that we have to do in order to develop our schedule. So in part 1, we'll define the activities using the WBS, then we'll sequence them in the order of occurrence, and then and only then can we begin to estimate our activity resources. In part 2, we'll be discussing duration estimates and the creation of the schedule. The entire time management process is laid out here. First, we're going to define the activities and identify specific schedule activities that need to be done to produce the deliverable. Then we will sequence them in order by identifying dependencies or relationships between them. Then we can estimate our activity resources: how many, who, what, where, when, why, and how. Estimating durations can then be done. Once we know who the resources are, we can figure out how long things should take. And then and only then can we develop the schedule and maintain our baseline. So that's the entire time management process, spanning 2 different lessons, because there's a lot of stuff that we have to do to create that all-important schedule. Very first step is activity definition. Basically what we're going to do is take the work packages and then break them out into individual schedule activities. They will be decomposed into smaller activities. They use the term activity. Try not to use the word task. I mean, it's about the same thing. But according to them, schedule activities will allow you to estimate, schedule, execute, and monitor and control project work overall. What do we use? Well, we use the scope baseline, which is those 3 documents. You remember what they are? Scope statement, WBS, and WBS dictionary. And of course, how your organization does this. You'll notice the main tool or technique here is decomposition, rolling wave planning, and if you have any templates or experts, use them. The outputs are going to be an activity list, any attributes that define those activities, as well as a milestone list that you can use to track performance. Now remember, I said they use the term activity rather than task. An activity has an expected duration. It involves resources or money. They like their verb-noun format: digging a trench, writing a chapter, or reserving a conference room. If I assign the correct resource to reserving a conference room, I should not have to explain how they should have to go about doing that. Okay, all I should have to say is reserve a conference room, it should take you an hour. These are all actions that are required to produce the deliverable or the end result. Tasks, on the other hand, are activities that do need to be broken down into further things that can explain a little bit better. For example, if I have a brand new resource and they don't know how to reserve a conference room, I might have to take that activity and decompose it down to the task level. You need to determine the size requirement, the date that's needed, alternative locations, if we're ordering food. Things like that are actual tasks. So if my project is to get up and go to work, getting up and going to work is the activity. The tasks are as follows: hit snooze, hit snooze, hit snooze. Major outputs of the defining activities sub-process will include an activity list. And don't get me wrong, this is comprehensive. This is all schedule activities that are planned to be performed. And they make it sound really easy. We jump from tools and techniques to major outputs. But this is probably one of the most difficult things that you'll do. Time management in general is pretty tough. You'll also list the attributes, any components, an ID number, an activity name, possible schedule, cost, or resource information. And you will use this for schedule development on the back end once we sequence and estimate. You'll probably also have a milestone list: mandatory milestones or optional milestones. Typically, mandatory milestones are set by the sponsor or the customer. You will start on this date, you'll finish on that date. Whereas optional milestones are designated by us so that we can track performance through the life of the project. The second piece is then to sequence the activities. In project software, this is the act of linking activities together. We are putting them in logical order, defining relationships: do this first, do that second, so that we can make sure that we have proper precedence and correct order. We'll also be discussing lead and lag time, which needs to be placed into the sequence to make sure that we're giving ourselves enough time to do the actual schedule activities that we've just sequenced. The end goal is to create a realistic schedule. Inputs, tools, and techniques include an activity list, the attributes and milestones list, as well as the project scope statement that we've just created. The tools and techniques include precedence diagramming method. Remember, we're doing this all longhand, so you're going to see network diagrams. Dependency determinations. What comes first? What comes next? There are 4 different relationships to be aware of. Lead and lag time, as well as any schedule network templates. Again, if you have templates, use them. This is comprehensive. Major outputs will be that network diagram that shows relationships and order of occurrence, as well as any updates to documentation so far. Activities can be sequenced in the order that they will be performed, and even project software will create a network diagram in a different view. So if you're used to working with these, then maybe you see that view in MS Project or other softwares. If you plot out your activities with time estimates or duration estimates, the diagram will ultimately be used to determine your critical path. So we're going to be doing this kind of the long way. What you see on your screen is a very small example of something called a precedence network diagram, the order of occurrence and the relationships between the activities. Relationships come in 4 different forms. These relationships will determine what comes first and what comes next, and how those are actually accomplished. Ultimately, once the relationships are designated and durations are assigned, we're going to use those relationships and durations to determine our critical path. This technique is also called activity on node and is typically used by most project management softwares. There are 4 main dependencies or precedence relationships. This is the act of linking in MS Project. Finish to start, finish to finish, start to start, and start to finish. You've probably used some or maybe all of these on a prior project. If you've never done this before, it can be a bit confusing. So I wanted to break down each relationship. The most common relationship is a finish to start. That means the first activity needs to completely finish before the second one can begin. So if I go out and buy a brand new computer in a box and I buy software brand new, both are in boxes. Can I load the software before I finish setting up the computer? I can't. It's not logically possible. I must finish setting up the computer before I start loading the software. How these little boxes or nodes work on network diagrams is the left-hand side is the start of the activity, the right-hand side is the finish, and where the arrow connects them will show you the relationship. So this is a finish to start. Ultimately, this is the most common relationship that you'll probably use on your projects. However, if you start thinking about durations between them, it takes 10 minutes to finish setting up my computer and 10 minutes to finish loading software. Both activities together equal 20 minutes. So that's not always the best relationship overall. Finish to finish relationships are not as common as a finish to start relationship. Basically, you have to finish something before you can finish documentation. This is typically used when you do a lot of software testing. I need to test it, document it, test it again, and document it, so that both are kind of finished at the same time. It's not as often used. However, I have used it on projects between some activities, but mostly I use finish to start and the next one, which is start to start. Start to start relationships mean there's parallel, there's overlap. I can start something and then start something else. I have a friend who asked me to help him out with some yard work, and basically he was trying to put in an irrigation system. So he said, listen, I need to finish digging the trench and then we can start laying the pipe. And I said, well, how long is that going to take? And he said 5 hours. And I said, oh, I don't think so. Here's what we're going to do. You're going to start digging the trench, go about 100 feet, and then I'm going to start laying the pipe behind you, and then we're going to cut this entire process in half. So start to start. This is a very common relationship found when you're trying to fast track or speed up your project. Ultimately, on the back end, when you're trying to move a bit faster in your project during execution, you can go back and look at finish to start relationships that could actually become start to start. So this is the second most common relationship used to speed up scheduling and to have overlap when the resource availability is there. The last relationship is what's called a start to finish. This is the most unique and least used relationship. Even though we think like this, you start the race, you finish the race.